We meet again. We're going to be talking about equations and formulas, kind of like we did in Unit 1, but a little different. And first off, in 95, we're going to talk about solving equations. And then in 96, it's going to be about solving equations without as many numbers, more letters. it's useful stuff. This is probably going to be the nicer one. Let's start with number 1. And by number 1, I mean number 4. It's really not like number 1 at all. Solve this equation, g minus 3 equals 10, and write as a reduced fraction if needed. G minus 3 equals 10. Where is my... Here we are. Oh, wrong color. Okay, so we need g by itself. G is getting subtracted by 3. So just like fractions, where whatever we do to the top, we have to do to the bottom. Well, here, whatever we do to the left, we have to do to the right. So notice that if I have g minus 3 equals 10, these things are true. Well, if I add 3 to both sides, it's still true, right? If x equals 3, then x plus 3 should still be 3 plus 3 because x is 3. You can do whatever you want to an equation as long as you do it to both sides. So that's really nice because the 3's cancel out. Minus 3 plus 3 is just 0. So we get g is 10 plus 3, which is 13. Where'd you go? There you are. G equals 13. We did it. And usually we don't write it out like this. Usually what we'll do is write it underneath, plus 3 like this. Then we can just add like so. 10 plus 3 is 13. Great. All right, next problem is going to be number 6. This is the same kind of idea. No, it wasn't number 6. Oh, it was number 6. Oh, no, I refreshed. So now it's different. All right, I wanted something like 8. All right, it's number 8 now. 7/11 of h equals 42. Now, there's a couple of ways you can do this one. All right, one way is to multiply by the reciprocal. That really works because then things cancel out. I'm going to do it the slightly longer way. Okay, so h, what's happening to h? In the last one, g, we were subtracting 3, so we undid that by adding 3. H is getting multiplied by 7 and divided by 11. So we can cancel out each one of those. It's getting divided by 11, so we want to undo that with multiplication. Let's multiply both sides of this equation by 11. Now on the right-hand side, we get 462, maybe. And the left-hand side, that one's easier. Multiplying a fraction by 11, multiplying fractions, 11's the same as 11 divided by 1. They're the same. And then we can cancel because we're multiplying. 7 times 11 divided by 11 is just 7. All right, the colors are really losing it. And now what's happening to h? H is getting multiplied by 7. So what we need to do is divide both sides of the equation by 7. Now on the left-hand side, the 7's cancel, and we just get h by itself finally. And the right-hand side is is 66. I actually can't do this in my head, but I know that 462 is 42 by 11. And 42 by 11 is 7 times 6 times 11. So the 7's cancel, and I do know what 6 times 11 is. So if you thought, whoa, nice math, Jason, that's how I did it. Let's check whether we're right. Okay? Because that's the nice thing about equations. Yes, I know it's my open math. We can just type it in and see if we're right. But if it's not my open math, how do you know whether you're right or not? Well, solving an equation is just finding the value that makes the equation true. So a solution to an equation, this is a solution to the equation, is a solution if it makes this true. So what is 7/11 times h? Well, if h is 66, 7/11 times h, well, let's do this. Well, we get a little cancellation. There's 1/11th here, and there are 6/11ths here. Okay, so now we have 7 times 6 is what's left over, which is 42. Oh, great. We wanted it to be 42. It is a solution. That's what it means for something to be a solution. It's a good way to check your answer. 66? Is that what we said? Great. All right, next up, let's do 12. This last part of 12. Oh, lots of negatives. Negative 10 times negative 11x plus 7. Minus 2 equals 9 times x plus 8. The hardest part is just copying it down. Answer is an integer or a reduced fraction. Okay, so before we do anything, we just want to simplify each side by itself. Before we have to solve the equation, let's just make it simpler. Then to make it simpler, we can simplify with order of operations. PEMDAS, if you will. So we start by simplifying what's inside the parentheses. But we can't. They're not like terms. Negative 11 times some number plus 7, there's nothing we can do there. They're not like terms. If they were all x's, they were all numbers, it would. But this is an x and this is a number. We can't combine it. So we have to start doing other things. Again, we tried to do what's inside the parentheses. There's no exponent, so we'll do multiplication and division next. So multiply is distributing here. The negative 10 times negative 11x is positive. A negative times a negative is a positive. 110x. When you multiply things with variables like this, you multiply the number part and you multiply the variable part. And now we have negative 10 plus 7. It's going to be a negative 70. We still have the minus 2 from before. 9 times x is 9x. 9 times 8 is 72. Is there something supposed to be here? I think there's something supposed to be there. There's supposed to be a 6 there. We still have the plus 6. If we forgot it, we'd sure as heck find out when we checked our answer. All right, now let's keep simplifying. On the left-hand side, there's nothing else with x's. So this guy stays by itself. But we do have two numbers that we can pool together. 110x minus 70 and minus 2 more is now minus 72. We were down 70 and then we were down 2 further. We're down 72 now. And it's the same on the right. 9x, that's all alone. No combining anything on that. But there's the numbers part. Plus 72 plus 6 is plus 78. Now we want to get the variable by itself and the numbers on the other side. Doesn't matter which side we choose for which. I usually like my variables on the left, but either side is fine. So we need to move this guy over. This guy is getting added. These are getting added together. So to undo that, we will then subtract a 9x from both sides. Now let's look at this calculation real quick, because this one over here is easy. They just cancel. But on the left, we have 110 x's, and we're losing 9 of them. Well, if we had 110 of something, we're losing 9 of it. How many do we have left? 101 of them. So we have 101 x's left over. And then it's still being subtracted by 72. And the right-hand side, these cancel. We're just left with the 78. We want the x's by itself, so we need to get rid of that 72. Let's add 72 to both sides. Because now on the left, great, 101x is by itself. And the right-hand side, 78 plus 72, you could type that into a calculator and should get 150. I'm not going to check this one by hand, but you could. Finally, x is getting multiplied by 101. So to undo that, we have to divide it by 101. And now the left-hand side cancels, and we just get x is equal to whatever this is. Is 101 prime? 150 is 3 times 5 times 2 times 5. Well, this doesn't have 3, 2, or 5 as a factor, so it doesn't simplify. 150 divided by 101. This is a reduced fraction. How'd we do? Whew. Good. Watch out for negatives. Simplify both sides first. And then slowly but surely try getting all the variable to one side and all the numbers to the other. Let's look at some inequalities or inequations. It's not consistent, right? We say solve an equation, but we say solve an inequality. How come it's not equation inequation or equality inequality? The wording is not consistent. I don't make the rules. All right, let's look at number 15. So this is just some notational stuff. So complete the table below. Each row represents something different. So we got a lot of practice. We're probably not going to do all of them. We got we got an inequality notation. We're going to be graphing that. And we have interval notation. All right. So we were looking at all the numbers bigger than 1, strictly bigger than 1. And remember, if you forget which one's bigger, is x the bigger one or is 1 the bigger one? The bigger one, it's a hungry alligator. The alligator's trying to eat the bigger one. It's silly, but it works, okay? And if something works, I don't care how silly it is, I'm going to use it. Just wait until you hear my quadratic formula song. Okay, so alligator eats the bigger number. X is the bigger number. X is bigger than 1. That's what this means. So we're looking at all of the numbers that are bigger than 1 to graph. So if it were bigger than or equal to, we'd use a closed circle. If it's strictly bigger, we use an open circle. Looking at all the numbers that are strictly bigger than 1, all the numbers that are to the right of this dot. These are all the numbers bigger. So let's get a nice arrow. Ta-da! And then in interval notation, how do we do that? So interval notation is always the smallest number on the left, biggest number on the right. The smallest number in what we've graphed, right? The smallest number is 1. Add a comma. What's the biggest number? Well, we go up to 10 on this graph, but there's an arrow, right? It can get as big as it wants. As big as it wants means infinity. This is always smaller number on the left, always the bigger number on the right. And then we finish with either parentheses or brackets. X is not included here, so we use a parenthesis. Parenthesis because X is not included. It's not bigger than or equal to. 1 is not part of the graph. Open circle, 1's not part of it. And similarly, infinity is always a parenthesis. Because infinity is not a number. We can never include infinity. It's not a thing, it's a concept. We go up to infinity, but we don't touch it. And certainly don't go beyond. Buzz Lightyear, I'm looking at you. Okay, so that's what we'll get here. 1 to infinity. You can click the infinity button and end the parenthesis. Let's see how we did. 2 out of 12. I think that's full credit. We got 2 things right. Oh yeah, there, it's right. Let's do a couple more. Less than or equal to. Oh, so now it's equal to, so now we'll have a closed circle. We need to find -2 right here. All the things to the left, like so. What's the smallest number that we can be? Infinity. Whoa, that's not true. Negative infinity. What's the biggest number we can be? -2. -2 is included this time, so it has a bracket. Don't fall for the autofill here. We can never touch negative infinity. So even though it looks weird that they're not the same, Infinity and negative infinity always have parentheses. Now let's go the opposite way. This is -4 up to positive infinity. The graph really makes this so much easier, I think. Start with the graph. -4 is not included. It has a parenthesis. So we use the open circle. Find -4. There it is. And now it's all the numbers between -4 and positive infinity. So let's zoom off over here. What inequality is this? It's all the numbers that are strictly bigger than -4. And that looks like so. Let's do some more of these. These can be tricky. -1 up to 3. Well, -1 is included. It's got a bracket. 3 is not included. No bracket. How do we write this one? We can write this with a compound inequality. So -1 up to positive 3. Let me introduce that real quick. And there, like this, right? Yep. So we want all the numbers with x being bigger than or equal to -1 and smaller than 3. So a compound inequality is just putting these together in a single inequality. So the first thing I'm going to do might blow your mind. I say that sarcastically. It's kind of weird, but it can be confusing. What happens if I switch the order? What if I put x on the right-hand side? Alligator always eats the bigger number. If the alligator's eating the x over here, well, the alligator should still be eating the x here. It looks like this. These are the same thing. So when you're solving inequalities and you get this, be careful. This is a less than or equal to sign, but it means -1 is less than or equal to x. It's like, if I'm shorter than you, you are taller than me. It's the same idea here. X is bigger than or equal to -1. That means -1 is less than or equal to x. Alligator opens to the bigger guy. So we want both of these true at the same time. So what we do is we just kind of smush them together. -1 less than or equal to x, less than or equal to 3. And this is our compound inequality, right? It's just this, but instead of writing x twice, we just smush them together. So let's type that in. -1 less than or equal to. You can type less than and then type equal to. That works. X is less than 3, like so. Hopefully it likes that. All right, and then these last two I don't think are anything really new. So let's just check the ones we have and then we can move on. Uh-oh. Oh. I said in an earlier video, I make silly mistakes too. It's -4. Whew, I panicked there for a second. I was like, uh-oh, what did I do? There we go. It's all right. Last thing in this video, solving equations. This video got a little longer than I expected, but hopefully it's useful and helpful. Let's solve the bottom, the right two inequalities. Okay. So it's pretty similar to solving an equation. It's almost the exact same as solving an equation, but if you divide or multiply by a negative, divide or multiply by a negative, you have to switch the inequality. That's not how you spell switch. Okay, so we'll see that in this first example on the right, -8x is greater than or equal to -16. So we need x by itself. We're dividing both sides by -8. Woo! Alarm bells. Divide or multiply by a negative, switch that inequality. So it's a greater than sign. Now it's a less than or equal to sign. On the left-hand side, they cancel out. It's just an x. On the right-hand side, a negative divided by another negative is a positive, and 16 divided by 8 is 2. And remember when I said, what is the solution of an equation? And I said, solution of an equation is something that makes it true. It's the same thing for an inequality. I'm saying that every solution, every x value that's 2 or smaller is going to make our original equation true. So if you pick anything that's 2 or smaller, oh, interval notation. All right. If you pick anything, 2 or smaller, it should make this true. Is that true? Pick something. Negative 8x greater than or equal to negative 16. I'm going to pick something smaller than 2. How about 0? If x equals 0 should make this true. If I plug in 0, negative x times 0 is equal to 0. Is 0 bigger than negative 16? Yeah, it is. Okay, so interval notation. Let's say 2 is right here. We're looking at all the numbers less than or equal to 2. So we use a closed circle and go to the left. Okay, what's the smallest number in this interval? What's the biggest number in this interval? 2 is included. Negative infinity is not. We get negative infinity up to positive 2. Does it let you do that? No. Negative infinity up to positive 2. And sometimes the answer won't exist. I don't think that's any of these ones though. I'm going to, instead of doing the second one, I'm going to show you something else. So what if I asked you to solve this equation? 2 times 3x plus 5 is less than or equal to, or strictly less than, 3 times 2x minus 10. Hopefully this works like I want it to work. Okay, so we want to simplify both sides first, just like solving an equation, and then get all the x's by itself. So when we distribute, 2 times 3x is going to be 6x, plus 2 times 5 is 10. And we need this to be less than 3 times 2x is 6x, minus 3 times 10 is 30. Want those x's by themselves? Let's move them over to the left. They cancel out, and we get 10 is less than, what do? We're looking at all the values of x that make this true. What value of x is going to make 10 be smaller than a negative number? There aren't any. There's no x that makes this true. I'm really going on a long video today, but it's important. There's no x that makes this true. No x works. There is no solution here. The solution does not exist. Pretend this is one word, please. There's no solution. But if we were doing a slightly different problem, and let's say we're doing some problem and we get to something like 2 is less than 5. And we're asking ourselves, well, what do we do? There's no x's anymore. How do we finish this? Remember what solutions mean. Solution just means it makes it true. So what value of x would make something like this true? It's always true. I don't care what x is. 2 is smaller than 5. We're not going into any weird hypotheticals here. 2 is smaller than 5. You can take that to the bank. I don't think people say that phrase anymore. So if you get to something like this, any value of x makes this true. If this is true, no, it doesn't matter what x is. It's always true. So our answer in this case would be negative infinity up to positive infinity. Watch out for these special cases. Sorry for the 25-minute long video. Hopefully you didn't watch it all at once. You can break it up into little pieces. And good luck. Let me know if you have questions. Bye-bye.